We're going to continue on in this idea of chemistry and life, what goes on in chemistry. One of the things about chemistry is this idea of diffusion, the concept that a solute disperses through an area, like perfume through a room, or like what I have here is my handy dandy Cafe Verona coffee beans from Starbucks. Now, when I open this up, I can smell the coffee. It's a wonderful smell. It's a beautiful smell. The smell starts here, and it's right in front of me, and I smell it really strongly. But the little kind of molecules from here that are actually what that smell is made of, they start here, but then they start floating around the room. They start getting separated from one another until the smell of coffee fills the whole room. You see, the particles that made the odor, they start out highly concentrated around the coffee and not anywhere else. They move from the high level of concentration in the coffee to into those areas where it's lower level of concentration until they fill the whole room. That's the thing. Anything will move from an area of high concentration to an area of low concentration. So if you spray perfume in one end of the room, it's going to smell really strongly there. It's going to diffuse out through the room until it's everywhere. It won't smell as strongly, but it'll cover more area. Just like the smell of my coffee won't be as strong in the whole room, but it'll cover the whole area. Now, in terms of water, you have a special kind of diffusion called osmosis. Now, the thing about diffusion, or that travel from high to low, doesn't take any energy. It just automatically does that no matter what you do. Well, osmosis is the diffusion of a solvent over a selectively permeable membrane. So what you see before you is you see two beakers. And basically in each of the beakers, they have this membrane between an area with a high concentration of sugar in the water and an area with a low concentration of sugar in the water. Now, the thing is, when you look at the little spaces in between them, they're too small for those sugar molecules to fit through, that they hit the membrane and they just bounce off. They can't actually get through. But the water flows through those holes in the membrane, no problem. Well, now, the sugar can't go anywhere, but everything wants to be equal. It wants to diffuse. It wants the concentration, the amount of sugar in the water to be the same everywhere. So since the sugar can't go from the side where there's a lot of sugar to where there's a little sugar, instead the water goes from the side where there's a little water to where there's a lot of water. Because of that membrane, because only the water can move, the water moves. And you end up with this weird thing where there's this much water and sugar on the other side and this much water and sugar on the other side, but they have the same amount of sugar per water. They would taste the same. So in that first one, on the one side, it would taste really sugary. On the other side, it would hardly taste sugary at all. After osmosis, both sides taste the same. Both sides are the same amount of sweet because the water moved over to make the concentration equally the same. Osmosis looks weird. It looks like things are going the wrong way from low to high, but they're not because of the membrane. Now, there's a solvent that's part of a solution. A solvent is the thing that dissolves the other thing. So here I have my handy dandy cup of coffee because coffee is important. Now, coffee is going to be the solvent. Now here I've got some sugar. The sugar is going to be the solute. And I'm going to take and I'm going to put the solute in the solvent and stir it up. Now when I stir it up, there ain't no more sugar. The sugar's gone from inside. I can't see it anywhere, but it tastes sweeter. The water, the coffee, is the solvent. The sugar is the solute. The sugar in the coffee is a solution that now has me having sweet